I want to make a Python function to calculate the standard deviation. Now, I know that there exists these functions already, but I'm using web VPython and it doesn't have that. So I'm going to build this. So if you don't know what the standard deviation is, it basically tells you how spread out a set of data is. And so the standard deviation sigma is the square root of the sum of each element minus the average element squared divided by the total number of elements. Let's make this function in Python. I'm going to use it in another thing that I haven't made yet, but I'm just getting ready. Okay, so let's jump over here to Python. This will be fun. I'm actually kind of excited. And I'm doing this 100% from scratch. I think I probably have done this in the past, but I don't remember. So I've already put some data in there. I called it nums for numbers. Get it? Haha. And let's just make a function. I'm trying to decide if let's just make a function. So let's def std. Let's just call it, and let's pass it a list of numbers, and I need to call that something different. Let's call it stuff. That's fine. Data. Can I use data? I think so. Okay, so I'm going to pass it a list that I'm going to call data. And I should put a comment in here. Data is a list of numbers. Okay, so the first thing, I don't even know how long that list is or anything. So let's get the length of that list. So n equals len data. Len returns the length, I'm pretty sure. And let's just put return. I feel like maybe we should just make this not as a function first. I do better if I just make it first. So let's just print in. That way I can test stuff as I build it. And see, good thing I tested, huh? Data. Oh. Data. Let's just change this to data. Okay, 6. Good. 1, 2, 3, 4, 5, 6. See, it's just, you gotta test even the little things because you forget, and that's fine. You could get some, that's fine. Let's just do it. Okay, now the next thing I want to do is to, I need to find the average of this list, and that's my x bar. So let's say for x in data. I'm just going to show you how this for loop works. Print x. So for x in data goes through the list data, and it calls each element x, and then I can do whatever I want with that x. So this is going to print out all the numbers. See? Print them out. Okay. I don't want to print them out. What I want to do is to say this. xt equals 0. That's my total. And then in my list, I'm going to say xt equals xt plus x. So I'm going to go through the list. I'm going to add each number to xt, and then I'll give me the total. And then we could print that if we wanted to. So I can say print xt. That should be the sum of the numbers. 14.6. So 1, 2, yeah, that looks good. Okay, that looks right. But I don't really want that either. I want the average. So I'm going to say I have xt. I'm going to say x bar for my average is equal to xt divided by n. Print x bar equals x bar. So that's the average. I think that's right. I'm not even going to check it. I think it's right. So now I have the average. Now I need to go through every list, take the difference between each element and that average, square it, and then get a temporary sum. And then I can find the standard deviation. So let's call this something. Let's call this sig temp. It's not the standard deviation. It's just part of it, right? Is 0. It's not even that. So again, for x in data, I'm going to go through each element, and I'm going to take the x element. Let's see, sig t equals sig t plus x minus x bar quantity squared. So if you look back at the that summation sign over I, xi minus x bar squared, that's that. So I'm going to have that part. That's not the whole standard deviation though. And then I need to find the standard deviation. I'm going to say sigma, let's call it sigma, equals the square root of SIGT, that's that top part, divided by n. And that's it. And let's print that. And I don't even know if this is right, but I don't really care. Print sigma. let's put std data equals the standard deviation. Okay, 1.17. I don't even know if that's right, but I know how to test that, because let's say I added a larger number in there. If I increase the spread of the numbers, then my standard deviation should increase also. Let's just test that. So let's go up here and try change this to 6.1 and 0.1. So I've definitely increased the range, and that went up too. Okay, so I think it's working. Now let's turn it into a function. So I'm going to call this stuff. No, I'm going to call this num. So that's what I called it before. And then I'm going to say def std stuff. I think it'd be, let's just return the standard deviation. I was going to return the average too, but let's not. So now all this stuff I want to indent. If you highlight it and press tab, it indents the whole thing. Now I have in data, everything looks good. I don't want to print this sigma. I want to return that. Return sigma. And then I can say print std equals std of nums. And I don't get the same thing. Can't find the variable data. Oh, I called it stuff. That's why. Same number. So it looks like it's working. If you want to test this further, we can. We can make a random list of numbers. Let's do that. This would be fun. Let's just use this. Okay. So I'm going to say n equals 0 while n less than 100. I'm going to do 100. I need to make my list. So stuff, I'll put up here. Stuff 2 equals an empty list. And then stuff equals stuff 2 plus, I'm just going to add a random number between 0 and 1, which is kind of boring, but random, that's it, random, a random number. Now I have my list, and I'm going to print std stuff 2 equals std stuff 2. It's that easy. I guess we could print. I don't want to print out that list. It's too long. Oh, you know what? I did a mistake. I know what I did wrong. I didn't increase my value of n in my counter. Now it's going on forever, and I didn't save it. So that's the end of this video. I hope you enjoyed it. I'll have to kill this tab. But we built a function, and we can use that function in a later program. So if you copy that standard deviation function, it works. It's not the best function. It's not a perfect function, but it's my function. And that's the important thing. It's my function. Stop.